Now, this example here is asking us to solve the system of equations. And as you know, we have a choice. We can either try to graph them, use elimination, or use substitution. And when we look at the problem here, we see that we have a y that actually is pretty much on its own right here in the first equation, which means that it's going to be easy to isolate that variable, and it's going to be easy to use substitution. So I'm going to take that as my choice, and I'm going to take the first equation, and I'm going to work on getting y by itself. So the first thing I'm going to do is I'm going to subtract the 2x from both sides. So I get y is equal to negative 2x plus 4. And then next I'm going to multiply everything by negative 1, changing all the signs. And so we get y is equal to 2x minus 4. Perfect. So now remember what we do next. We take what y is equal, we're going to circle that, that's 2x minus 4, and we plug it into the other equation. It's important that you don't plug it back into the same equation that you started with. So let's see what we have now. This equation becomes negative 4x plus 2, parentheses, 2x minus 4, is equal to 5. Excellent. So we're going to distribute negative 4x plus 4x minus 8 is equal to 5. Now here the 4x's cancel and we get negative 8 is equal to 5. Well, this is a problem because negative 8 certainly does not equal 5. So the first thing you ask yourself is, did I do something wrong? But the answer is no, you followed your steps correctly, you did everything you were supposed to do. And your y's disappeared, but your x's also disappeared. And so what we see is that during this process, we ended up with a false statement. Negative 8 equals 5. What does a false statement mean? Because we want to solve a system. Well, a false statement means that there is no solution to this system. Okay, well, what does that mean? That means that no matter what we try, there's no x and y that satisfies both equations, which really means at the end of the day that these two lines are parallel lines. They never cross. There's no point of intersection. So there's no point, x comma y, that lies on the first line and also lies on the second line. So that's the solution to this system. Now notice that we ended up, as I said, with a false statement, but what if we had done this problem and the x's had also disappeared, but we'd ended up with something that looked like, for example, negative 8 is equal to negative 8. Well, that's a different situation because negative 8 does equal negative 8, and that's a true statement. So what's the difference between getting a false statement and a true statement? Well, a true statement means that there are infinite solutions to this system, which means that you can take any x comma y that you want, and it will work if you plug it in. It'll work in the first equation, and it will work in the second equation, which means that these two lines are actually the same line. They lie right on top of each other. And so every point from the first line is the same as every point on the second line. So when you're doing these problems, when you're solving systems of equations, it's very important if your x's and your y's both disappear to pay attention. Do you end up with a false statement, meaning no solution, or do you end up with a true statement, meaning that there are infinite solutions and these are the same line?